The reason dividing is done separately, okay, is that the domain is a little bit different when you get to the dividing. Unlike adding and subtracting and multiplying, where you just have to find the overlap of the domains, dividing adds non-permissible values because you can't divide by 0. Here are two notations, f of x divided by g of x, f divided by g of x. I've also seen this one written like this. No, not like that. Like that. And for whatever reason, when you see the other notation, and I'm going to see if there's a nice value in here. We'll do -2 again. If you see a notation like this and they add a number, for whatever reason, students freeze up and get stuck. So if you see that notation, take the time to say this is the same as f of -2 divided by g of -2. What's f of -2? That's on our red graph. It's 0. What's g of -2? It's on our blue graph. It's 3. 0 divided by 3 would be 0. So, yes. Oh, I guess the other notation that they haven't written is that. And that's probably, that fraction notation is probably the best one. So I'll put a fancy yellow box around it with a smile inside. Nice, that's the best one. Okay. So if you had to do f of 2, well, the f of 2 is on your red graph. The y value is 2. G of 2 is -1. 2 divided by -1, that's equal to -2. And so we get our green graph. So we still have an overlap of the domain. Notice that your green graph starts here. But now we have added in here an asymptote at x equals 1. What were the points that we said were important for dividing? Well, whenever the function on the top, and the red function is the one on the top of the function, is equal to 0, that's equal to 0. So that was important. We also talked about wherever our red and blue graph are the same, when you divide, they're going to be equal to 1. So that's why the green graph is at y equals 1 at that point. We also talked about dividing by 1 doesn't change anything. So dividing by 1 there. The other thing is dividing by -1 takes that 2 and just makes it a -2. But that's just taking some nice points and figuring that out as well. So those are some key points. Other things to notice. A positive number divided by a positive number is positive. A negative number divided by a negative number is also positive. But if one of them is positive and one of them is negative, your entire graph is going to be in the negative section as well. So our domain for f of x was everything bigger than or equal to 2. Our domain for q of x is everything bigger than or equal to -2, but x can't equal 1. So we have to add that non-permissible value into our domain for the quotient. So let's do example 2. F of x is the square root of x, and g of x is x minus 2. So again, I'm going to quickly draw graphs of these. F of x, the square root of x, that's in green. And I'll label that f of x. And g of x I'll do in red. Y-intercept of -2, slope of 1. There's our graph of g of x. What are the domain and range for both of those? Well, for the green one, the domain is bigger than or equal to 0. The range is bigger than or equal to 0. And for the red graph, the domain is everything. The range is everything. Now we're going to look at what happens when we do f of x divided by g of x. Again, if you want, you can create a table of values, right? This is for f of x, which is the square root of x. And we can do a table of values for g of x equals x minus 2. And then figure out a table of values for the quotient. Because all that you're doing is dividing the y values. Now with the square root graph, you have no negative numbers. So in our table of values, I'd probably put 0, 0. I'd put 1, 1. I probably wouldn't do 2. I mean, you could write 2 square root of 2, but square root of 2 isn't a nice number to work with. I'd probably just put a couple of nice numbers to work with. Square root of 4 is 2, square root of 9 is 3. And then I would say to myself, well, if those are the y values I've chosen for my green graph, where do they happen on my red graph? Well, at 0, I have negative 2. At 1, I have negative 1. At 4, I have 2. At 9, I would have 7. So if I took the green one divided by the red one, 0 divided by negative 2 is 0. 1 divided by negative 1, negative 1. 2 divided by 2 is going to be 1. And 3 divided by 7 is 3/7. So it gives me a sense a little bit about the points that I'm going to have on my black graph. I'm going to have, again, should put my x values in here. I'm going to have 0, 0. I'm going to have 1, negative 1. I'm going to have 4, 1. And 9, 3/7. Unlike other times, I don't really get a sense of what this graph looks like by drawing my points. Because you could connect those in a bunch of different ways. Another key thing is looking at, we're dividing by our red graph. Our red graph has an x-intercept right here at 2, 0. And when we have that, we would be dividing by 0. So that's going to add an asymptote, a non-permissible value at x equals 2. So right away, from what we know from before, our domain for our black graph will be x is bigger than or equal to 0, but x can't equal 2. Because that's a non-permissible value. And that also includes the overlap of both of those graphs. Now, as far as graphing it goes, just some things to observe. And I'm going to view entire page here so we can see the original red and green graphs above. Can you see that between 0 and 2 for the x values, that your green graph's always positive. But between 0 and 2, your red graph is negative. A positive number divided by a negative number will always be negative. And so our graph in this section has to always be negative. Then in the section after x equals 2, in that section after x equals 2, your green graph is still positive, but now your red graph is positive as well. And a positive number divided by a positive number will always be positive. So as far as going towards this asymptote, that now tells you have to go up towards that asymptote. Because if you went down towards that asymptote, you'd go into the negatives, and that would not be allowed. And connecting these points, it appears that there also may be an asymptote at y equals 0. And there is in this case, but you don't know why that is yet. When we write, here we go. When we write the range, So an interesting thing happens here with the range. Even though there's a partial asymptote here at y equals 0, the range is everything. Because if we go from our smallest value include all these negative numbers, and they go up to 0 and include 0 there. And the asymptote says you get as close to 0 on the positive side as you can possibly imagine. And it does go up forever, so the range is everything. If we wanted to write an explicit equation of what this looks like, the explicit equation for q of x, that's just writing f of x on the top, so that's our square root of x on the top, and g of x on the bottom. This would be our explicit equation. So algebraically looking at the equation, we can see from the square root that we can't take a square root of a negative, so that makes sense that the domain is bigger than or equal to 0. We can also see from that equation that if we put in 2, we'd be dividing by 0, so 2 is going to be a non-permissible value. Question? A horizontal asymptote? Remember when we did, was it chapter 1 or chapter 2? No, chapter 2, our rational and radical equations, that our horizontal asymptotes tell us what's happening at the extreme big values of x, either positive or negative. That sometimes our graph crossed through a horizontal asymptote in the middle. Okay? This is one of those times. We have it hitting, starting at 0, 0, because that horizontal asymptote is just telling us when x gets to like billion, right, that it's going to get close to 0. Think about it. You put a billion in for x. What's going to happen on the top? You're going to take the square root of a billion, which is going to make it considerably smaller, right? What's going to happen on the bottom? You're going to take away 2 away from a billion, which is not going to make much difference at all, right? And so you're going to have a number that's smaller on top and a bigger number on the bottom. Square rooting makes it a lot smaller than subtracting 2, right? You're at work and they say we're going to take pay cuts, right? Everybody's going to have to lose $2 off their pay cut. Or you can choose to square root your pay cut. Probably makes more sense to, that was not intentional, to take the $2 off rather than square root it. Unless you're making a really low amount of money, right? If you're only making $1 an hour, square root it. You'll still be making $1 an hour. But if they take off $2, you have to pay $1 every time you come to work. So I would stop going to work until they fired me. And if that was the case. If you're making $4 an hour, it's the same. And then you'd be in this dilemma like my kids. I can't make a decision. I don't know what to do. Okay, questions you can do for practice 6, 13, and 16. You can draw it as a half asymptote. You can draw it all the way through. Again, that horizontal asymptote is just showing what happens at extremes. Although it feels somewhat wrong, doesn't it, to have a point go through?